You know, it's easy to think of our skin as just, well, a surface, but it's actually buzzing with life, a whole ecosystem. And one of its most common residents, this bacterium, Cutibacterium acnes, plays a way more complex role than we used to think.
That's absolutely right. For the longest time, the story around C. acnes, and people might remember it as Cutibacterium acnes, that was its old name. It's
Yeah.
pretty straightforward, the villain in the acne story. But recent science, it's really blown the doors open on its world and, all the different things it does.
Which leads us to something really cool today. We're not just looking at the lab reports and studies, we're also diving into the super imaginative world created in the Cütie Catcherz AR comic series.
Yeah, it's a fantastic project. It takes all this detailed scientific knowledge about C. acnes and skin health and weaves it into this engaging story. It even personifies the microbes as these little characters called cooties.
Exactly. Pronounced just like the word we all know from childhood, cooties. A listener sent over a great batch of sources, everything from the latest C. acnes research papers to info on the Cütie Catcherz story and its characters. So our mission for this deep dive is to really get into both. We want to unpack the key science insights and then see how this comic translates that science so creatively. Hopefully it helps you understand your own skin a bit better too. Okay, so the science first.
Let's start there. The basics of Cutibacterium acnes. It's super common, lives deep down in your hair follicles and sebaceous glands. Those are the little oil producers in your skin.
Right in the thick of it then. And it's not just sitting there, is it? It's active.
Oh, yeah. It actually feeds on sebum, that oil your skin makes. And as it metabolizes the sebum, it releases different molecules. Some of these can, promote inflammation. And it also sheds these tiny packages called extracellular vesicles, or EVs.
Okay, inflammation, EVs, sounds like potential ingredients for acne, right? Is that the connection?
It's definitely part of the picture, but maybe not in the way we originally thought. The big shift in understanding is that acne isn't just caused by having more C. acnes. Studies actually show people with acne don't necessarily have a higher quantity of this bacteria compared to people with clear skin.
Wow, okay, that changes things. So if it's not just about how much, what is it about?
It's much more about balance. Think of it as a tight equilibrium. A healthy skin microbiome depends on having the right mix of different types or phylotypes of C. acnes, along with all the other microbes living there. When that diversity goes down or the balance gets skewed, that's when you can see issues like acne pop up. It's a state called dysbiosis.
Dysbiosis, so an unbalanced ecosystem leading to trouble. Makes sense.
Exactly. And our understanding leaped forward thanks to genetic studies. They revealed so much about how unique C. acnes is that it actually got reclassified, moved from the Propionibacterium genus to Cutibacterium. That name change really emphasizes its specific link to the skin.
A name change reflecting deeper knowledge, that's pretty significant.
It really is.
Yeah.
And with better DNA tools, things like MLST, multi-locus sequence typing, and others, we can now differentiate between these various phylotypes much more clearly. We talk about types like IA, IB2, and 3. And even within IA, there are subgroups like IA1 and IA2. There was a bit of naming confusion early on as techniques evolved, but now the field is mostly using IA1, IA2, IB2, and 3.
Okay, so it's not one monolithic group. There are distinct families almost.
Precisely. And here's where it gets really interesting for acne. Certain phylotypes seem to be more involved than others. Phylotype IA, and especially the subgroup IA1, shows up much more frequently in studies of moderate to severe inflammatory acne.
Ah, so IA1 is often found at the scene of the crime, so to speak.
You could say that. Whereas phylotypes IB2 and 3, they tend to be more common on healthy skin. Now, it's not perfectly clear-cut. Some of these healthy types have occasionally been linked to other kinds of infections, deeper ones, but they aren't usually the main players in typical acne flare-ups. Some studies even show that in inflamed acne spots, you see more IA and less IBN2, suggesting IA might actually sort of thrive in that inflamed environment.
Like it takes advantage of the situation.
That's a reasonable way to look at it. And genetically, these acne-associated strains, like IA1, seem to carry specific genes, virulence factors that might make them more problematic. Phylotype 2, often found on healthy skin, has different genetic features, maybe explaining why it shows lower activity of certain enzymes like lipase, which breaks down fats.
So their genetic toolkit might predispose them to causing issues or not?
That's a big part of the current thinking, yes. But, and this is crucial, it's almost certainly not just the bacteria. Acne severity likely comes down to a complex mix. The specific C. acne strains present, how your immune system reacts to them, and other things like environmental factors.
Right. It's never just one thing in biology, is it?
Rarely. And even within these phylotypes, there's variation. Take lipase activity. Some strains produce more propionic and butyric acids, and those have been found more often in severe acne cases. On the flip side, a specific lipase called GABE seems linked to healthier skin and a more diverse C. acnes community, maybe helping maintain that balance.
So many layers to this. It's not just the type, but what that type is actually doing.
Exactly. And what they're doing includes interacting with our immune system. Different phylotypes can provoke different levels of inflammation by affecting immune signals like IFN-gamma, IL-17, and IL-10. Although I should mention the research here isn't always perfectly consistent. Sometimes different studies find slightly different inflammatory potentials. Like one study suggesting phylotype 3 could be quite pro-inflammatory. It's complex.
Sounds like scientists are still mapping out all those immune interactions.
They definitely are. And another huge piece of the puzzle is biofilm formation. C. acnes doesn't just float around solo. It can build these organized communities. Think of slime cities, almost, encased in a protective goo. Specific genes help them stick together into surfaces in the follicle.
Slime cities. Okay,
Yeah.
like building little fortresses.
That's a perfect analogy. And these biofilm fortresses are bad news because they make the bacteria much more resistant to things like antibiotics. They also seem to ramp up the activity of enzymes like lipase. And interestingly, these C. acnes biofilms seem to be found more often in people with acne. Plus, a single biofilm can contain multiple phylotypes living together, like IA and T coexisting.
So they team up in their fortresses.
Pretty much. And this leads directly to another major concern, antibiotic resistance. It's a growing problem globally, especially resistance to common acne treatments like erythromycin and clindamycin.
Yeah, you hear about antibiotic resistance a lot. How does C. acnes become resistant?
Mostly through changes, mutations in their own genes, specifically the ribosomal RNA genes. Sometimes they also pick up external resistance genes, like one called ERM-X. And guess which phylotype is often linked to resistance against erythromycin, clindamycin, and even tetracycline to some extent?
Let me guess. IA1.
You got it. Phylotype IA1. We're also seeing some resistance in other types, like IC, and even emerging resistance to another class of antibiotics, fluoroquinolones, in IA. What makes it tricky is that each follicle can be like its own little world, maybe housing a mix of resistant and non-resistant strains. And remember the biofilms. They add another layer of protection, making antibiotics less effective, even if the bacteria aren't technically resistant genetically.
Wow. So resistance is complicated by the specific strain, the mechanism, and these biofilm structures.
Exactly. So wrapping up the science part, the big picture on acne and C. acnes isn't just too much bacteria. It's way more nuanced. It involves which strains are present, the balance between them, how they interact with your immune system, environmental triggers, whether they form biofilms, their specific virulence factors.
Okay.
Oh, and even how they interact with other skin bacteria, like Staphylococcus epidermidis.
It's a whole dynamic microscopic drama happening constantly. Okay, so with that detailed science picture in mind, let's switch gears to Cütie Catcherz. How does this comic take all that complexity and, well, make it understandable?
This is where Stephen Christian's creativity really comes in. He has this background that blends science and art, and he's used it to build Cütie Catcherz, specifically to make health science engaging and, frankly, fun.
And the core concept involves these cooties, the personified C. acnes, right?
That's the heart of it. The cooties are these little microbial characters. They have personalities, they evolve, they cause different kinds of trouble, directly mirroring the different C. acnes phylotypes and their behaviors we just talked about.
Okay, so how does the comic translate specific scientific ideas, like the different phylotypes?
It's pretty clever. The different phylotypes, IA1, IB2, they're represented as different types of cooties. Some might cause just minor issues. Maybe they look relatively harmless initially, while others are shown as more aggressive or capable of mutating, reflecting that variable inflammatory potential we see in the real bacteria.
Makes sense. What about biofilms? How do they show up?
The biofilms become biofilm nests in the comic. These are depicted as slimy, sortified structures that the cooties build to protect themselves, making them harder to deal with using simple methods. It's a direct visual for biofilm resistance.
And those little packages, EVs?
Ah, yes, extracellular vesicles. In the comic world, these are shown as things like toxic spores or little cloud bursts that agitated cooties release. And just like the real EVs, these spores trigger inflammation in the story's world. The body's immune response itself is shown as how the world or the characters react to the cooties. Sometimes they go unnoticed, other times they cause huge, angry flare-ups, representing things like cysts or nodules.
So visual metaphors for invisible processes, it's brilliant.
It really is. And the story mechanics, even the gameplay elements, if it's interactive, tie back to the science. Like if there's too much sebum, too much oil, in the comic that's shown as fuel that helps the basic cooties grow and spread faster.
Clear link. More oil, more cootie fuel. Simple.
And the idea that some C. acnes are just normal residents, commensal, while others can cause problems, pathogenic, that's represented by showing some cooties that can actually be calmed down, or maybe even converted to a less harmful state, perhaps using special items in the comic world, like chamomos.
Like trying to nudge the balance back towards healthy.
Exactly like that. Inflammation, the cytokine release, that gets depicted visually maybe as burning areas, red zones, or the cooties themselves looking really agitated and angry. And those tough biofilm nests. You need special tools in the comic, like whips of wrath or sun drops, to break through their defenses.
Sounds like specialized treatments for tough problems.
Precisely. And antibiotic resistance gets represented too. You might see certain evolved cooties that shrug off standard attacks, forcing the characters to use combination strategies or teamwork, mirroring how we have to tackle resistant infections in reality. The story even hints at things like hormonal shifts causing surges in cootie activity, which lines up with real-world hormonal acne triggers.
It's amazing how tightly they've woven the science into the narrative. Can you give some specific story examples?
Sure. There's a point where these seemingly innocent pink cooties start appearing everywhere in Iltopia, the comic setting. It's a great visual for the start of dysbiosis, that quiet shift in microbial balance. Later, these basic cooties can actually transform into meaner versions, showing how that initial imbalance can escalate. They even talk about Cütie Clouds, representing this widespread dysbiosis causing chaos.
And the main character, Nimbus, he doesn't start out with the most sophisticated approach, does he?
Not at all. Initially, he's all about punching the cooties with his cootie popper's gloves. It's such a clear metaphor for aggressively picking or scrubbing at pimples, which, as we know, often just makes inflammation worse.
Yeah.
Another character even calls him out on it, like, hey, maybe just punching isn't the answer.
Huh. That's very relatable. What about deeper acne, like nodules?
Yeah, the comic has hardened cooties forming nodule nests. These are tough, resistant to surface attacks, symbolizing those deep infections, often involving biofilms. And that's where tools like the whips of wrath or sun drops come in, representing treatments designed to penetrate deeper.
So the tools represent different skincare strategies or treatments.
Exactly. And there's a pivotal moment where Nimbus gets frustrated and uses this massive EMP bomb to try and wipe out all the cooties. But it causes huge collateral damage. His friend Pickles has this great line, "You can't burn the whole garden just to kill a weed." It's a fantastic metaphor for using overly harsh, broad-spectrum treatments that damage the entire skin microbiome, not just the problem bacteria.
Wow, that hits home, like using something too strong that irritates everything.
Precisely. But Nimbus learns. He starts working with mentors, the Paw Patrol, who teach him about more science-based approaches. He then develops targeted weapons, like a Serenity Mist, and uses precision tools like phage darts or probiotic pods. This whole arc represents shifting from brute force to smarter strategies, aiming for microbial rebalance, breaking down biofilm specifically, maybe modulating the immune response gently rather than just nuking everything.
So he learns to work with the ecosystem, not against it.
That's the core lesson. The big bad is King Cootie, described as a biofilm boss, representing that really stubborn chronic biofilm infection that resists simple attacks. The turning point for Nimbus is realizing he needs to find balance, symbolized by awakening his inner prime cutie and grasping the idea. You don't fight the biome, you balance it. The story ends with a big team effort, combining everyone's unique skills and tools, a metaphor for a holistic approach to skin health. And the final message is all about maintaining that balance through informed care, teamwork, self-care, even emotional wellness to prevent future outbreaks.
It really sounds like Cütie Catcherz goes way beyond just being a fun comic. It's like a masterclass in skin science disguised as an adventure.
I think that's a great way to put it. By giving these microbes personalities and using these really vivid, relatable metaphors, it makes incredibly complex processes much easier to understand and remember. It shows why acne happens, why different factors matter, and why different approaches are needed, just like the real science tells us.
Okay, so let's boil this all down. What are the absolute key takeaways for everyone listening from this whole deep dive into C. acne science and the Cütie Catcherz world?
I think the main thing is recognizing C. acnes isn't just one thing. It's complex, with different types doing different jobs, some helpful, some potentially problematic. Acne itself is usually less about just having too much bacteria, and more about an imbalance, the wrong types dominating, or interactions going haywire involving inflammation and those tricky biofilms. And definitely keep that antibiotic resistance issue in mind. It's a real challenge.
And Cütie Catcherz offers this brilliant, engaging framework to actually visualize and understand all of that complexity.
Exactly. It translates the science into memorable characters and situations. It helps show why just trying to obliterate all bacteria might not be the best strategy, and why aiming for balance and using targeted approaches like Nimbus learns to do makes a lot of sense scientifically.
So really, understanding the science behind your skin, maybe even thinking about it through these Cütie metaphors, can actually empower you to make smarter choices about taking care of it.
Absolutely. It encourages shifting perspectives, seeing your skin not as a battlefield, but as an ecosystem that needs careful tending to stay healthy and balanced.
Right. So maybe a final thought for everyone. Take a second to consider that amazing, complex ecosystem on your own skin. Think about the balance, the different players involved, maybe even picture your own little cooties. How might different things, products, stress, diet, be influencing that balance? Perhaps dive into some reliable info sources with this new perspective. You might just see your skin and its microscopic residence in a completely different light.
You got the cooties, we got the cure, fighting breakouts with facts and a whole lot of lore. It's Cütie Catcherz, beneath the skin, where science and story are about to begin. Let's go! You got the cooties, we got the cure, fighting breakouts with facts and a whole lot of lore. It's Cütie Catcherz, beneath the skin, where science and story are about to begin. You got the cooties, we got the cure, fighting breakouts with facts and a whole lot of lore. It's Cütie Catcherz, beneath the skin, where science and story are about to begin. Let's go!
That's a wrap on this episode of Cütie Catcherz Beneath the Surface, where science meets art and technology, and skincare gets a superpower treatment. If you learned something, laughed a little bit, or just loved the blend of art, culture, and biology, make sure to follow the journey at CütieCatcherz.com and stay up to date on Instagram at CütieCatcherz. Catch every new episode on Spotify and YouTube. Just search Cütie Catcherz Beneath the Surface. And remember, the cooties are real, but so is your power to fight back with knowledge. This is produced by me, Stephen Christian, of Stuck on an Island, in collaboration with Iltopia.